Hello everyone, in this video we are going to take a look at how you can create your own virtual texture. For this example, we are going to use this blue marble downloaded from Lhasa. As you can see, the image has 21,600 by 10,800 in pixel dimension. And we are going to slice it up into appropriate chunks and put them into corresponding folders and create the CTX virtual texture definition file and also the SSC solar system catalog file. Before we start, I find it very useful to learn about projection mapping. For that, I have two resources for you. The first one is this page, and you can find some usages within Celestia. It talks about various projection mapping methods. The other one is this page, and I'm going to share the links in the video description. Specifically, this one we are using here is called a cylindrical projection, which wraps the sphere inside a cylinder. And for simplicity and for the purpose of this demonstration, we are going to use this cylindrical projection format, and we are going to output tiles that are exactly 500 by 512 pixels wide and 512 pixels height. So I'm going to show you how this projection thing works inside Blender. Here we have a sphere, and if you select the sphere, you can do something called unwrap sphere projection and make sure you do align to object, because by default it probably is something else. If you do align to object, the resulting mapping here, as you can see, is going to be the corresponding point to the 2D space. So as you can see, if I just randomly pick some location here, in 3D space it's on the sphere surface, but in 2D space it's becoming this kind of 2D structure, and then at the top it's all mapped into this kind of structure. So naturally, at the very top there is very strong distortion. In fact, all the way from the middle point, the equator up, there is more and more distortion because of the way the surface area is compressed into, expanded onto this 2D surface area. And here, if we just give it some texture, then we will be able to paint things on top of this. So let me just pick some color. We will be able to paint things on top of it. If I give it a material and also assign the texture we have here, image texture, and here I'm just going to pick the one we have painted here. See here. So if you can have your continent here, you can have your Lost Pole here, right? And then you can have your ocean somewhere here, right? So that is basically how the 2D image is going to be mapped onto a 3D sphere. And in this particular case, we're using cylindrical mapping, which also I would like to call it equirectangular mapping. So that is projection mapping. Now, if we go back to the folders that we will be creating, there are a few technical details I want to get us through first. First, the images that you create, which are put inside this levels folder, they do not have to be of exact same dimension. So for our purpose, we always have 512 by 512. But here, let me just show you an example. Here I have this particular one, and this is as level 2 for one coordinate. If we show it in Celestia, and if we go to Earth, you can see the one we were looking at is going to be, oh, that's the other side of the sky. Let me just let the time go, so we can see it right here, right? So for one, that's the one we have right here. Now, if I add the text so we can identify it and then output it at a much higher resolution, and then I'm just going to place in the same folder with the same name to override the existing one, and then I'm going to close Celestia and launch it again. And now if we go to Earth, you can see that the whole thing, oh, I still need to make sure it goes to the correct place. 4, 1 is still shown here, right? So it doesn't really matter the exact image dimension as long as you follow the convention of putting it into the corresponding folder and give it an appropriate file name. The next point I want to address is regarding missing tiles. You do not need to have the entire coverage at each level. If you do not have the coverage, what you are going to see is simply lower level picture. For instance, for the Mars, for the blue marble, I have level 0, level 1, and then for level 2, it's incomplete. And then I'm just showing some reference tiles. So if we go to the blue marble, you can see in general it looks nice, but if we let it rotate and go in, you can see there will be some tiles that are simply missing, right? So at this detail level, if there is a tile, it's going to be drawn. If there's no tile, it's just going to draw the lower resolution version of it. The last thing I want to address is regarding base split. So base split, this is actually specifying an exponent. The 0 here is going to be 2 to the power of 0, which is going to be 1 or 2, doesn't really matter. But what it really means is if it's 0, it means at the level 0 is going to be 2 images. And then at level 1 is going to be 4 times that. So for our purpose, it's convenient to always use the base split of 0. That way, it's just going to split the whole thing by half in the first level and then 4 times more in the next level. So those are some of the technical details. Now, to create those images, you can have a host of ways to do that, as long as you understand the conventions. Practically, though, I believe it's almost never created by hand, because dividing it by hand, you can use Photoshop, Affinity, whatever way you want, but I believe it's always going to be doing in a program. So for that purpose, I have this Celestia Tools, and specifically we are going to use Virtual Texture Reference Set Generator. And you can find more information about that on this particular video, Celestia Tools and Resources. And again, we are using the blue marble from NASA. So to use this tool, it's a command line tool, and the usage is fairly straightforward. You can unzip it and open it in a terminal. And you can find the available commands by typing virtual texture reference set --help. And in our case, we are going to use the first command, which is shown here. So we are going to specify an output folder, my outputs, and then you're going to specify the tile size. The by default is 512, so we don't need to change that. And then you can just specify the number of levels you want to output. So for this demo, I'm going to just output the first 3 levels, and then the source image. In this case, because I was already doing that, that's the path to the source image. You can run this one. It's going to go through it and generate the corresponding tiles for each level, and also generate those 2 files that is going to be placed inside the add-on folder. So here, actually, this file is going to be placed right next to the high-resolution textures. So here we have this one, and you can see the whole thing is split according to the convention. I believe that's the correct way to do that. And then you just need to place those into the corresponding folders, as we mentioned previously. So here, just to recap, you have this specification that mentions the folder, and then inside the SSC file, you have this, you need to change this to something like so Earth. So that is basically how you can create your own virtual textures. The last thing I want to point out is now what happens if I want to do a level 4, right? So if you do a level 4, you don't want to specify all the details. You need to pick just exactly which part of the original image you want. So in order to do that, what you can do is, again, use one of the tools available here called Virtual Texture Preview Picker. So here, I'm just going to launch it. It's a GUI program this time. And then you can double click or Control O to open an image. And here I'm just going to navigate to the blue marble, and then it's going to show you all the divisions within that particular image. You can use plus sign, minus sign to reduce the dim. And then if you use the mouse wheel, you can divide it. Now we're at level 2, level 4. Level 4 is like this. And then you can pick whichever region you want. For instance, I'm going to control mouse wheel to zoom in. I'm just going to find this region. So this is 24 by 4. So if I do a right click, then you can output it directly. Here it's going to give you a template name, but you need to name it properly into level 4, and then give it the name like tx24 for save. That is going to create just the level 4. So that's it. That's how you can create your own virtual texture. Thank you for watching.